In this video, we're going to help you find what the adjacent side of a right triangle is. I recently started the trigonometry unit in my class, right? And by far, the number one question my students had is, which side is the adjacent side? So I want to show you a nice, easy way to figure that out today. Then we're actually going to solve these problems and figure out what those missing sides are using our adjacent side. Now, when it comes to finding these missing sides in right triangles, we first want to always find our hypotenuse. The hypotenuse is always going to be the side across from our right angle. So in this case, in this middle triangle here, I'll maybe highlight this one in purple. It's going to be this side, right? What's the missing, or what's the side across from the right angle in this triangle? That's going to be this side over here. Again, I'll kind of highlight this in purple. All right, and then what about this one? Is it the Z, the 7, or the blank? It's going to be the blank one. All right, so again, kind of highlight that there in purple, okay? So once you know the hypotenuse, then it's really easy to find the adjacent and the opposite. Those are our three choices, right? Adjacent, opposite, and hypotenuse. Because compared to the angle that you are given, right? In this case, I'm given angle down here is 32. Well, the opposite is going to be the one clear across from it. So usually in these problems, you're given an angle, or maybe it says like, this is triangle A, B, and C, and it's going to ask you what the adjacent side of C would be. And so you know the opposite is going to be the 11. I'll highlight the opposite here in pink, and that means that our adjacent in green is going to be the one that's remaining, right? The one that's next to. You might have heard that before. The adjacent is next to. Well, you might think there's two that are next to. Well, if you know that one's the hypotenuse, the other one has to be the next to leg. All right, what about this one over here? If this is the hypotenuse, right, our opposite compared to our 67 is going to be this leg. And so the adjacent is going to be the Y there in green, right? Opposite of the 39 is the 7. So I think I'm doing that one in pink. And then the green, the adjacent side, is going to be this one here in green, which is the Z. All right, now why is this helpful? Because when it comes to finding some of these missing sides, we can use our word soh-cah-toa. I'll put that over here maybe. S-O-H-C-A-H-T-O-A. It's more important to know how to spell it than it is to say it, because the order of those letters is very important, all right? Let's take our calculator here. And when it comes to finding the missing side X in this one, what two sides do I have? I have information up here. Remember the pink, that's our opposite. And then the adjacent, the green one. In fact, all of these, I think, have one that's green, and so we're going to use the adjacent in all of these. If I have the opposite and the adjacent, the O and the A, that's going to be my T for tangent function. So I'm going to say tangent of 32. And then this OA is important because I'm going to say equals that fraction where the O is on top, the A is on the bottom, in that order. That's why it's important to know how to spell that word. All right, and so here the O is 11, the A is X. When it comes to solving this, you always want to multiply by what's in the denominator. In this case, X, X, and X, and those are going to cancel. So now I have X times the tangent of 32, and it equals 11. Well, I need to get that X by itself. Currently, it's being multiplied by tangent of 32. That's just a number, and I can divide by tangent of 32 on both sides. And so if it cancels on this side, because it's both being multiplied and divided by tangent of 32, I'm just left with X. And then in the calculator, I'm going to type in 11 divided by tangent 32, tangent of 32, and this gives us 17.6. So 17.6 is what the X is going to be in this case. Oops, not 16, 17.6. 17.6. All right, let's try this one. Compared to this 67, we have information on the adjacent. Remember, that's our green side, and our hypotenuse. So adjacent and hypotenuse, that's going to be cosine. So here I'm going to say cosine of 67. And again, with cosine, the A comes first, the adjacent is Y, and then the H, the hypotenuse, is 6. All right, so to undo this divided by 6, I'm going to multiply by 6. You always multiply by what's in the denominator. You got to do it to both sides. All right, and so here I'm going to have 6 times cosine of 67. They're going to cancel on this side, the 6's are, and it's going to leave me with Y, which is what I want. So here I'm going to do 6 times in the calculator cosine of 67. and I get 2.3. 2.3 is what I'll say equals y right there. 2.3, which is good. Remember, your hypotenuse always needs to be the longest side. 6 is still longer than 2.3, so that's good. All right, last one. Compared to my 39, I have the opposite and I have the adjacent. Again, I kind of highlighted those earlier for you. Opposite and adjacent, again, is our tangent. We'll go a little faster on this one. Say tangent of 39 equals the opposite 7 over the adjacent z. Always multiply by the denominator, which is z here. So I have z tangent of 39 equals 7. To undo this, I'm going to divide by tangent of 39 on both sides. Just like that. It's going to cancel on the left side, leaving me with just z, which is good. On the right side, I'm going to type in the calculator 7 divided by tangent of 39 and get 8.6. 8.6. So if I plug this in here, 8.6, then you can see that we got all of those missing sides using our adjacent, right? So find the hypotenuse first, and then you can find the opposite, right, of what we have here. If this is 67, the opposite, and then that leaves you with your adjacent. So hopefully that helps you find the adjacent side of these right triangles.